Hi everyone, my name is Renee and I work for the Beacon Foundation. A very warm welcome to our 7th Industry Live event for 2020 on jobs in science, research and environment. We just wanted to say a big thank you to those that are watching with us today. Well done on taking those important first steps in a potential career in science, research or STEM. And Beacon is very pleased to be able to continue providing you with these fantastic online events using our online platform. Today's session, we are going to explore what scientists actually do and take a look at some innovative areas of research that are working on problems in our environment. We have two impressive panellists that are going to inspire you today, no doubt, in all things science. So first off, we have Sam. Sam is a senior chemist working for a biotech company. Hi, Sam. How are you going? Give us a wave.
Morning, Renee. Fine, thanks. Hope everyone's well out there.
Great. And secondly, we have Aleks. Aleks is a research scientist and quantitative ecologist. Hi, Aleks. How are you? Good to see you.
Hi, everybody. Good morning.
Great. We'll find out more about what those jobs actually mean as we go through today's session. But before we get started, now that we are all gathered and ready, we wish to acknowledge the traditional custodians of all the lands across this nation that we meet upon today. We wish to pay our deepest respects to all Aboriginal and Torres Strait Islander peoples and to their elders, past, present and emerging. I also wish to extend that respect to any First Nations people joining us here today. Okay, so how things will run today. We're going to have a chat to Sam and Aleks, alternating between the two of them, to get a feel for what they actually do as scientists and researchers. And I'm sure you'll come away with some amazing insights after the session. Students and teachers, for those joining us in the live webinar today, don't forget you can key in anytime a question in the Q&A function, which is down the bottom of the page where the chat box usually is. We encourage you to tick the anonymous box when asking questions, please. So let's try the Q&A feature now. For those attending the live webinar with us, please, if one person from your location can key in the name of your school and how many students are with you at that location, that would be great. And with that, let's kick off. Our first panellist is Sam. Sam is the senior chemist at Marinova, which is a biotech company that's focused on the research, development and manufacture of high purity fucoidin compounds. And in case you haven't heard of those before, it's seaweed. So Sam has a PhD investigating catalytic chemistry, and in his current role oversees the lab function at Marinova, which performs testing and quality assurance of all of their products that are made on site. So he works closely with the factory that processes the seaweed and purifies it. Sam's going to talk to us about his job and what he does day to day there at Marinova, and will also share with us what he thinks are the most important qualities every good scientist should have. And we're also super excited because we get to go on a bit of a tour around Sam's lab, and he's going to talk us through that a bit later on. But first we're going to dive into a couple of questions. So welcome, Sam.
Thanks, Renee.
Good to see you. So let's start off by, immersing ourselves in what scientists really do. And also, if you can tell us a bit about the work Marinova does as a biotech company and how your role supports the work that they do.
Yes, of course. Good morning, everyone. So Marinova, as Renee has said, we extract and produce fucoidin compounds. Now, fucoidin's not necessarily a thing many people have heard of. So they're a kind of polysaccharide, or you might know the term carbohydrate better, and as a storage polymer like starch. But they're not like what you get in potatoes. They come from brown seaweeds. Marinova's been extracting these for some years now. The company originally came around because there was an infestation of seaweed on the east coast of Tasmania. And some years earlier, the original starters of the company got a license to clean up this problem. But then some very clever scientific-minded people that they knew realised that, wait a minute, this wasn't just a pest that would be thrown away. There might be something quite useful in there. So the company began producing extracts. So we now extract this compound out. And it turns out Phacoidin, the stuff that came from this pest seaweed, has a lot of great uses in human health. So it's known to be antiviral. It can be anti-inflammatory. It can be good for gut health and all sorts of things like this. So what we do now, that, and this has been optimised and continues to be optimised over many years, is we extract from some particular species of brown seaweed. We extract Phacoidin compounds at a very high purity, and then we sell those to other people. So we don't have retail lines ourselves. You can't buy product from us, like you can't buy a tablet, but a lot of our customers then incorporate into nutritional supplements. We have customers who do medical research and make medical devices. And there's people at universities doing research into new and interesting ways you can use this material. So it's a very interesting area, and it continues to be lively for generating new research. So the seaweeds, as I suggested, originally came from the east coast of Tasmania. It's actually invasive. So the species you'd better know is wakame. If you've ever had miso soup, it's the green seaweed that's floating in it. So that's the main species that we were cleaning up. And this had arrived from some boats years ago and took hold over the local ecosystem and was causing all sorts of trouble. So we continue to use that. The Tasmanian problem isn't there anymore, so that comes in from overseas. There's another species that I'll just call fucus for now, which comes from the North Atlantic. And that's still a brown seaweed, but has a different kind of Phacoidin in it. So we focus on those two main kinds, generate a number of purities of compound from that.
That's great.
So,
I've probably, no doubt I've had potentially some of that product in supplements and things that I use. So yeah, that's awesome. And it's a great introduction, I think, that you've just given to the world of biotechnology and your role within it and what your company's doing. And as you've said, your company processes and analyzes seaweed extracts, mainly, as you said, for human health, through the supplements that other people are making. But it also has a focus, by the sounds of it, on environmental sustainability in processing and sourcing your seaweed, as you've said, from other parts of the world. So can you tell us just a little bit? I know you've sort of said that you've got a few different places around the world where it comes from. Can you just sort of talk to us about that, those places they come from, and how you, some key points?
Yeah, absolutely. So yes, now because the pest's gone from Tassie, we still do harvest here a little, but it's only a trivial amount. The Undaria we get actually comes from Argentina, and there's a spot right down the coast it's in the area called Patagonia, which is much on the same line of latitude as Tasmania, and there's a huge amount of seaweed just grows off the coast there. So that's our partner in that species. The fucus species, we go to nice, clean, cold waters, as I said, in the North Atlantic. So we have partner companies in Nova Scotia, which is off Canada, and Brittany in France. And they both harvest their seaweeds there. As far as the sustainability and being aware of the natural world goes, we are very conscious of not being a drain on the world and its resources. So all our seaweed companies use wild harvesting techniques, which means they don't farm it, they don't harvest more than is there, and it kind of regenerates itself. So they only harvest according to seasonal growth cycles, then dry it naturally and keep it as natural as possible. We have a lot of organic certifications which help customers believe that our process is as close to natural as we can be. And everyone we obtain seaweed from has to have those certifications as well, so that we can comfortably say, yes, right back to the very source, this is as clean as it can be, and we try and keep it as close to natural as possible.
Yeah, it's great. It's amazing. And so great to hear that not only you're helping individuals, but your company's committed to moving towards minimising the impact on the environment from your products and processes too. So that's amazing. And we're very excited now that you're going to give us a tour of the lab that you work in. And so for our young people today, what an amazing opportunity to have a bit of a look inside a real live working lab. You know, some of you guys out there now might end up pursuing a career where you will be in a lab-based scientific role. So this is going to be great. So Sam is actually using his phone. We normally, you know, like to do these sessions on laptop, but so that we could have a really good look around the lab, he's using his phone. So he's going to be walking around the lab and showing us all of the cool things he gets to do in the lab and some of the machines that he gets to work with. So Sam, head off, as you go, probably pan out and have a bit of a look.
I will. I'll just turn off selfie mode. There we go. Okay, so here's a very quick pan around the lab. I'll just, before we look at some instruments, I just thought I'd show you some actual seaweed. So this is whole wakame, which I spoke about, or Undaria is the botanic name that we talk about. So that's what you get in your miso soup. This is the same plant, but that's actually, it's called sporophyll, which is the reproductive part. And I spoke about fucoidin, which is the compound we like to extract. There's far more of it in here. So we tend to use that in the factory when we're extracting our products. This, as it is in that whole nice form, though it's kind of pretty, it's not very good for doing an efficient extraction. So before we go and extract fucoidin, we get it ground down into a fine powder. So you'll see that there. And then that, when you have that in contact with a water-based medium, that's far more efficient way of extracting things that you want to. So the lab has a lot of interaction with the factory and the production facility. There are a lot of tests that we have to do on an ongoing basis to ensure that their process is behaving correctly. As I said, so fucoidin is a water-based compound. If we look down here, these are some samples that we get from the factory on a daily basis. So fucoidin is extracted into a liquid. You get this nice brown stuff that accumulates in there. So that's a very high percentage of fucoidin, but it's still dissolved in water. So we get those and we do a couple of simple tests to check that the production procedure is going as it should. After it's extracted into liquid like that, they use a process called spray drying and they take off the water and we get these nice brown powders. So that's sort of fresh from the factory, but that's quite pure fucoidin. And that'll then get subject to a lot more tests as we go from there.
And what other sorts of tests are you doing on those samples, Sam?
Okay, so I'll take a walk over here. There's a lot of chemical properties of fucoidin that you have to test separately. So it's not a simple molecule like something like Panadol, which is one discrete molecule. But these instruments are called a UV vis. We'll get samples that are nice bright colours and tell us how much sugar's in there, how much phenolic compounds are in there and other such things. Depending on the product, we've got between 3 and 6 full tests that have to be done, which can take some days. We have to keep very close control on microbial content. Now, being a plant, there's often bacteria and microbes there, and you can have some, but a very low limit because, as I said, because people make nutritional products from our extracts, people need to be able to eat these. So we do our very own in-house microbial testing, and that has to be done to a very close level. So if you look in this cabinet here, this is quite interesting. It's called a laminar cabinet, and this is where we can test for microbial content without contaminating ourselves. So this is an interesting box. It blows a stream of air back towards the operator as it's running, which means if you've got a bug on your hand, which you shouldn't because you should wash your hands, it can't get inside and contaminate the test plates. And even the vials you'll see in there, they're the vials we'll use for microbial testing, but they're being bathed under ultraviolet light, which will kill any leftover bugs before we start doing some testing in there. So there are a few few test plates in here, and there's no spot on that, which means they haven't grown any bugs yet, so that's a good outcome. So yeah, there's lots of different instruments used. This is called an LC, or a liquid chromatograph, and that lets you, it basically shoots molecules down a really, really small tube, and then it separates them depending on how big they are. And that's some useful information that some of our customers like to know. If we go back into the lab, this is R&D, or Research and Development Lab. We'll see the fume hood. Now, this is the opposite of the laminar cabinet in the micro lab. So while that one blows air at you to keep bugs out, this one sucks air in to stop any toxic fumes getting at you. So there's some quite toxic chemicals that we have to use for our testing. There's no way around that, but this means that we don't get exposed to any nasty fumes in the process. So it's good to have those things in place. Sometimes we need to stir and heat things. So these are hot plates. Now you don't want to stir stuff with a spoon all day, so I can turn that on there. There's a magnetic bar that'll stir it for me. So we've often got, 5 or 6 of these going, stirring things that are at different stages of testing. There's some I prepared earlier. And then you can have quite a lot of experiments in process without having to stand at every one.
That's great. What a great view, and all the different machines and devices and different things that you're using. And Sam, just while we're heading back over, how many people could we expect to see in the lab working at any one time with you?
Probably up to 4. I mean, there's 4 staff in my lab office, and they bounce between desk and lab, I suppose, because you don't have, as I said, suggested, you don't have to be attending the experiments all the time. But yeah, there's plenty of space here for everyone to spread out and do all their things without getting in each other's way. So yeah, it can be quite a nice, vibrant workplace at times.
That's great. Excellent. Thanks, Sam. That was great. So good to see inside a working lab. And I think it's really important for our students watching today to really get a good first-hand look of what really goes on. And some of them may be involved in lab work in their future careers. So I think that's really great to see. Thank you. So we'll hear from you a little bit later, and we'll head on over to Aleks. So Aleks is a scientist who leads research into ecology management and conservation at the Australian Antarctic Division. His job involves developing and delivering science that helps us to understand where biodiversity is in Antarctica, what threatens it, and what can be done to reduce those threats. Aleks's research has a strong focus on improving environmental protection in Antarctica and the sub-Antarctic, including biosecurity. Can't wait to hear more about Aleks's fascinating work, and as if being a scientist and researcher wasn't enough, Aleks is also a wildlife photographer, and we'll get to have a look at some of his beautiful photography a little bit later that he's taken out in the field. So welcome, Aleks. Thanks for coming along today.
Thank you, Renee. Nice to be here.
It's great. So look, in case some of our young people watching haven't heard of the Australian Antarctic Division, can you talk to us about what the purpose of the division is and what your specific area of research known as quantitative ecology is within that overall purpose?
Yeah, sure. So the Australian Antarctic Division is actually part of the Australian Government's Department of Agriculture, Water and the Environment. It's a division of that department, and within this division there is a science branch, an operations branch that's responsible for getting people to Antarctica and managing Australia's Antarctic stations, and also a policy branch, which is responsible for understanding what Australia's policy needs are with regard to managing Antarctica, mainly through the Antarctic Treaty System. There's also a technology and innovation branch and an assets and infrastructure branch. So science is a key part of this division, and I'm one of the principal research scientists here within the science branch. With regard to quantitative ecology, well, it's, as the name suggests, it's about the numbers. And so I'm really interested in using numbers to help us understand ecology and in this case, biodiversity in Antarctica. And what does that actually mean? Well, it means that one of the things that I focus on is creating models that can actually link aspects of the biodiversity to the factors that drive them. So for example, we can get some real clarity around the environmental aspects that certain biology or certain biota or certain communities might like. And that actually helps us to understand why they're there, what might threaten them, and also, in many cases, what we can do to minimise those threats. I guess one of the things that I like about quantitative ecology, if I look a little bit more broadly, is that it allows me and it allows others to work on a whole range of species and ecosystems. And so it's very transferable, and hopefully when I sort of run through my career in images a little bit later on, you'll be able to see some of the opportunities that being a quantitative ecologist actually provides.
That's great. Sounds like an amazing area of research, and is one that I'm sure some of our young people watching today may not have even known about. So it's great. It's great to hear all about what's going on and what you guys are doing there. So you've worked on some amazing projects during your career so far and have had some real impacts on in environmental research and conservation. Can you tell us about a couple of those projects and the organisations you've worked with to achieve positive outcomes for environmental protection?
Sure. So I graduated with my PhD I graduated from my science degree in the sort of the mid-90s. And since that time, I've really tried to focus on science to, I suppose, support and improve or create good environmental outcomes. It's just been one of my passions. And so I've worked for CSIRO, I've worked for the state government as a marine biologist, and now I work for the Australian Antarctic Division, with a bit of a break in there, as you alluded to be a few years as a wildlife photographer. I guess really, if I want to think about some of the key projects for the state government, I worked on some of the invasive issues on Macquarie Island, which is a small island that Tasmania actually runs halfway to Antarctica. Now, Macquarie Island is an amazing place, but it has had in the past some real issues with species that weren't supposed to be there: rabbits, rats and mice, cats, a whole range of things. I think really being involved in the lobbying and the achieving the funding to get rid of to eradicate the rabbits, rats and mice was a really satisfying project to be involved with. Bringing it back to Antarctica, I think some of the more sort of quantitative research that I've done has looked at how we can understand bioregions in Antarctica. I led a team that produced a bioregionalisation of Antarctica, and what that did was actually show some of the biologically distinct regions across the continent, and actually was a really important step in understanding and managing the biology and the ecology of Antarctica moving forward. Also in Antarctica, you wouldn't necessarily think so, but non-native species or alien species, as we often call them, can also be an issue. And some colleagues of mine led a program whereby they actually vacuumed the jackets and the gear of a whole bunch of expeditioners that were heading south to try and understand the pathways of things like tiny little seeds or invertebrates that might be travelling to Antarctica. And by using science to actually quantify the magnitude and the extent of that problem, it really incentivised, it actually provided a lot of motivation for countries and what we call national Antarctic programs to improve their biosecurity and to make sure that there were things in place to make sure that expeditioners or cargo heading south didn't have as many unwanted visitors, so to speak. So there's a few key things that I've been involved in.
It's great. Thanks, Aleks. Great to get a first-hand insight into how important work of conservation, environmental protection in Antarctica, and how it moves forward, and how important science and research is to protect that. So we're really thrilled to now get a look at some of the wildlife and nature that you've captured on film and some of the things you've already spoken about already. But can you talk us through what's happening in these as they pop up, please?
Sure. And so what I've called this is a very brief career in images. And before I start on this first one, I guess it's just worth noting that, and I think this is relevant to what we'll talk about in a little while, is that when I left university, I started working for CSIRO as a marine biologist, and I was looking down a microscope, identifying zooplankton and contributing to fisheries research. And after about a year, I thought, is this really what I want to be doing for my foreseeable future? And an opportunity arose, a job came up on Macquarie Island as a field assistant on what they called the Albatross and Petrel project. And I applied for that job and got it, and ended up spending most of the next 5 years living in this little hut at a place called Caroline Cove at the southern end of Macquarie Island, studying the 4 albatross species for my PhD, and then eventually managing that project. And this hut was my home for many years, and I have very fond memories. And it was a great place to study the albatrosses. And there's just a couple of pics of the albatrosses coming up now. First up is the black-browed albatross, which I think should be coming up shortly. There we go. And this is one of my favourite species. There's less than 50 pairs of black-browed albatross breeding on Macquarie Island itself, so it's a small population. And part of the research that I was doing was trying to understand not only about the breeding biology, but we'd put satellite trackers on these species, understand where they were foraging. And again, this feeds into our broader understanding about things that might be threatening these species, for example, fisheries and climate change and changing oceanographic processes. Another species on Macquarie Island is the grey-headed albatross. And again, you'll see that a few of these include the albatross chicks because, well, there's not a hell of a lot more cute than an albatross chick when it's all said and done. They really are amazing little creatures. And you'll see the one in the background there has just been left unattended. And they stick around unattended on their nests and have to defend themselves against skuas, which I suppose are a bit like the predators of the sub-Antarctic. And they do a great job. One of their defence mechanisms is to expel the digestive oil from the recent food that their parents have just fed them. And as an albatross researcher, that's one of the hazards of the job, is that every now and again, as you walk past one of these chicks, if you give it a bit of a fright, they might expel some of that oil. And let me tell you, it takes a long time to get it out of your clothes. This is a wandering albatross chick. I was fortunate enough at one stage to spend 18 months on Macquarie Island, and it allowed me to see the sorts of transition from a very small chick at just a couple of months of age through a 10-month period. So this chick sat alone through the winter on Macquarie Island with regular visits from its parents, of course. But you can see that as this chick grows, it becomes a lot bigger, it loses its down, and eventually about a month after that last photograph was taken, it leaves the island and doesn't actually come back to the island for about 7 years. So they spend the first 7 years of their life without touching land at all. So that was my Macquarie Island experience. As I said, when I finished my PhD, I came back and managed that program. Still went to Macquarie Island, but also worked with a whole range of other species as a marine biologist, managing the marine conservation, or helping to manage the marine conservation program for the Tasmanian state government. It allowed me to get up close and personal with whales, both in the environment, but also, unfortunately, during whale strandings, which we had to attend on several occasions, where we tried to help the whales to get back in the water after they've been stranded. And this was also a really interesting aspect. I think the next photo is a picture of just sort of coming back to these non-native species issues. This is back to Macquarie Island. You'll see the rabbit in the right-hand top, and a beautiful, what we call tussock grass slope. The main picture is that tussock grass slope after rabbits have devastated it. And so this just sort of highlights the devastation that rabbits could do and why it was such a satisfying experience to be involved in their eradication. The rabbits were eradicated in 2011, and if we go back to Macquarie Island now, the island is recovering, which is a great success story. Just to finish up on the Macquarie Island side of things, I have a picture of the Aurora australis. This is the way that we generally made our way south, either to Macquarie Island or to the Antarctic continent. It's just finished its life. It's spent over 20 years transporting expeditioners backwards and forwards to the sub-Antarctic and Antarctic, and Australia now has a new research vessel that's on its way. It's nearly finished, and we'll be taking delivery of that early next year. But nothing sort of stays the same forever, and I suppose when my partner was offered a job in overseas and I agreed to move with her, I looked around for something else to do and landed on working as a wildlife guide and photographer for a company that did what they call expedition tourism. Now, this company went all the way from the Antarctic to the Arctic. This is a picture at a place called Cape Adieu in the Ross Sea, a very wild and beautiful place of Antarctica. And these are some of the lucky tourists that were participating in that trip. But this ship, it travelled all over the world, as I said. This is a picture taken right in the middle of the Pacific Ocean. Yes, next one, thanks. A flying fish. And let me tell you, when there's 6 or 7 days of just travelling through fairly sort of barren ocean landscapes, these flying fish become a really interesting part of the world. And of course, this ship also heads further north up to the Arctic, where we see things like killer whales in this next image. Amazing interactions with killer whales through these Arctic oceans, and other wildlife like walrus, which are up next, and of course the iconic polar bears, which we were fortunate enough to see on an island called Wrangel Island, which is part of the Russian Arctic. And so life as a wildlife photographer was great, but it wasn't for me forever either. And after doing this, I also wrote a few books. I decided to head back to research and got a job at the Australian Antarctic Division, where I started looking at the sorts of things that I sort of was describing earlier. This next photo is a picture of one of our field camps in Antarctica, and it's on one of the permanently ice-free areas in Antarctica, which is where I focus my research. And it's not just about the biodiversity that we all know and love, like these penguins, which are up next. It's also about some of the smaller things, the mosses and the lichens, and the tiny little invertebrates that live in these mosses and lichens, which I think is the next photo. These are springtails. Antarctic biodiversity is a lot more. There's a lot more to Antarctic biodiversity than just penguins, and so things like this are also really important. Just to finish up, I've got a picture of the Aurora Australis taking out of my hut balcony one day on Macquarie Island, and I guess this just sort of sums up some of the amazing natural phenomena that I've been fortunate enough to see over the decades of working in these amazing environments. Thanks very much.
That's great. What beautiful photos, and it's amazing, yeah, just for you to be able to capture all of nature in its beauty. And I think you also highlighted a lot of different things that you can do within science. You know, you've obviously married up a lot of passions as well. So for those interested in environment and conservation, science can cover that. You know, traveling obviously to all these beautiful places, you can do that with a career in science, and and photography. So yeah, it's great to see that you've been able to marry up a lot of those. So yeah, it's great. Thanks for sharing those. Now, Sam and Aleks, you're both obviously very successful scientists working in very different areas of research and development. And again, it shows the variety of scientific jobs out there, which is great. And so what advice do you both have for the young people watching today about the skill set and educational foundations that will set them up for success in careers like yours? So perhaps let's start with Sam. What is your advice about what subjects young people might find helpful to study at school and university, and what skill sets they'll need when they actually get out into the scientific arena?
Yeah, sure. So I think as to what subjects you do, the number one thing is that you've got to find it interesting, because that will drive your passion. And if you really want to enjoy something in life, then I think that's a good motive to have. Got to find it interesting to start with. If STM is something you'd like to get into, then the basics never hurt. So physical sciences, physics, chemistry, maths is very useful everywhere. But don't feel that if you've got an interest that's not particularly sciencey, as you might say, that you shouldn't do it, because you never know when those things might in fact overlap. I mean, you might get a job looking at assessing scientific patterns, which is not a very sciencey job in the stereotypical sense, but it's still very much relevant, and your science skills will be very important in understanding what you're trying to read there. So that's all very important. Skill set wise, attention to detail is a good one. You'll often find yourself needing to read and understand something new that you haven't heard about before, to look at a new piece of research. And so if you can be focused on that and all the really fine things that might affect your outcomes, that's really helpful. If you like reading, it probably helps. They're definitely useful, but yeah.
That's great. Awesome, thank you. And again, I think it just confirmed the young people just to you know, keep your options open and not to sort of pigeonhole yourself. There's obviously many areas that science can cover, so that's great. And obviously following what they love and interested in is obviously going to be helpful and help you love your job in the future. So that's great. Thanks, Sam. Now over to you, Aleks. What advice would you give young people listening today about skills and education, and what could help them build the right foundations in a career like this?
Yeah, thanks, Renee. I think Sam covered a bunch of really good points there, and I agree with all of them. I do want to reiterate though about doing things that you're passionate in. I think really you will always do better about things that you're passionate about, and I think for me that's been a real driving force through the subjects that I did. Maybe not so much in early high school, but certainly through the later high school years, and especially in university. You know, I went to university to be a physicist, and just did biology as a filler, essentially, in first year university, and ended up falling in love with it. And I think that speaks to the point about not trying to pigeonhole yourself too early. And as you start to think about the things that you are interested in university, just give yourself a few options, because university, if indeed you're going down that path, is a great place to explore those options. And I think that's a really important point to note. I think doing subjects like the various sciences and maths in the latter years of high school at the highest level that you can is important, because it sets you up really well for university. And the more well set up you are for university, the better you do and the more enjoyable you find it. And that's actually the best way to have to start off a successful career in science, is to actually enjoy your university and not feel daunted or that you're not sort of doing as well as you might be in some of these subjects. So I think there are a few of the key points that I just reiterate, I guess.
Yeah, that's great. Great advice from both of you guys. You know, on the different skills and education you'll need, and obviously still again both suggesting keep your options open, but making sure you're passionate and what you like doing what you're doing and what you're studying. And I think another good point that you made, Aleks, too, is that once you hit university, it isn't the end, as well as, oh, you've made that decision, you have to stick to it. You might discover other things that spark that curiosity, and you go on into a different area than you may have first thought. So I think that's really good advice. Now we're going to learn a little bit more about you, Aleks, as a person. We're going to move on to our first interactive poll for the day in the form of 2 truths and a lie. So for those joining us live in our webinar, what you will see are 3 statements that will pop up on your screen about Aleks, and we'll read them out, and then you'll need to guess which one is the lie. So I'm going to hand over to our beautiful Sophie, who will run through the poll for us. Thanks, Sophie.
Fantastic. Thanks so much, Renee. Okay, everyone, it's time for 2 truths and a lie about Aleks. So let's hear 3 statements about Aleks and see if you can guess which one is the lie. And for those watching on YouTube or the recorded webinar, you can still try to guess which one you think is the lie. So number 1, I have been chased by a polar bear. Number 2, I have been inside the stomach of a dead whale. And number 3, I have been on a ship that has hit an iceberg. Wow, okay, I'll give you a few more seconds to pop those answers in. Fantastic, alrighty. I'm going to end polling and share these results. Now, Aleks, everyone thought the lie was I have been on a ship that has hit an iceberg. Is that correct? Sorry, Aleks, you're just on mute. Yep.
Thank you. Yeah, that is correct. That is the lie. I have been chased by a polar bear. Fortunately, it didn't get too close. And I have been inside the stomach of a dead whale, because one of the things that we always tried to do at a whale stranding, if we did have a casualty, we tried to conduct an autopsy and understand as much as we could about the species and what was going on. And of course, understanding what was in its stomach. And the stomach of a sperm whale, for example, is quite easy. It's big enough for me to more or less get inside it and have a look around it. And so that's why it's not a lie. So yes, there you go.
That's great. Wow. I'm sure the smell was something to behold too, no doubt on that.
Yes, indeed. The smell it's hard to describe.
Yeah. Great. Thanks, Sophie, for doing that, and thanks, Aleks, for sharing. So moving on to our next question. Sam and Alex, you obviously both work in very interesting areas of science and research that must be both personally and professionally rewarding. But in the bigger scheme of things, why do you think roles like yours are important? You know, why should we encourage young people that are watching today to embark on their own fields of scientific endeavour? So perhaps let's start with you, Alex. Why do you think scientists and researchers are important?
Well, for me, you know, deep down, I feel like humans haven't done a great job of looking after the planet that we're on. And so I see science as a great way to provide a really solid foundation for managers and decision makers and those people that are making, I suppose, important policy decisions about the environment to actually have this information to base these decisions on and hopefully make better decisions. And I think for me, science can do that. And science, you know, in Antarctica, we talk about science as being the currency because it's such an important aspect of the presence of people in Antarctica. And I think that sort of sums it up for me.
Yeah, that's great. And I know certainly through my work, there are so many young people that are really interested in the environment and helping our environment. So science sounds like the perfect place for a career and to you know, explore that. So that's great. Thanks, Alex. I think that will really inspire some of our young people watching. Now over to you, Sam. Why do you think it's important that Australia and the world encourage and develop the next crop of young scientists coming through?
Well, I think in a sort of broad sense, I mean, human progress relies on having new ideas and thinking about new ways to deal with the world as we're faced. And you know, to those watching, especially if you're thinking about getting into STM now, you're kind of ideally placed to join the next cohort of new thinkers. You'll have new ideas no one's ever had before, and you know, the world isn't going to stop throwing challenges at us. But I think you're just in the right spot to get on board, helping us, become better, and we can do it. It's just, it's a matter of getting on board. It's just important.
Yeah, it's great. Thank you. I think, you might have rallied some troops there, Sam. Thank you. So now let's learn a little bit more about you as a person. We're going to move on to our second interactive poll of today, which is your 2 truths and a lie. So again, for those in our live webinar, as we did for Alex, the 3 statements will come up on your screen about Sam. Sophie's going to read them out and we'll need to guess which one we think is the lie. So I'll hand over to Sophie again.
Fantastic. Thanks, Renee. Okay, it's time for 2 truths and a lie for Sam. So let's hear 3 statements about Sam and see if you can guess which one is the lie. So number 1, I spent part of my PhD studying in London. Number 2, I think numbers are boring. And number 3, I sing in an a cappella choir. Okay, pop your answers in. Give it a few more seconds. Alrighty, here we go. I'm going to share these results. Now, Sam, everyone thought the lie was that you think numbers are boring. Is that true? Which one is the lie?
Yeah, nailed it. Is it that obvious? Yeah, I really quite enjoy numbers, so.
Excellent. And it says that you spent part of your PhD studying in London. How was that?
Yeah, it's great. If you get the opportunity to go and particularly work somewhere else, because as opposed to a holiday, if you've got time to immerse yourself in a different culture and just live and breathe that. This was 5 months when I went, but yeah, it was quite wonderful. Sort of one of those life experiences you just really have to go and do.
And it sounds like maybe you can sing us out later on and do some music, a bit of a finale with your singing.
We can't rule it out. I'd say on that passion's important, but you should have other passions that aren't work. It's good to have some balance there, and I think music's good for the soul.
I'm completely with you there. It's great. Excellent advice. Okay, thank you again. And look, we've heard about the amazing work that Sam and Alex do, as well as why they want to encourage you guys out there to get involved in science and research. So if you have any questions now for our panelists, please make sure to pop them in the Q&A section here. So we're just going to have a quick look and see what we have got? Now, let's see. So perhaps one of the questions that we can have a look at, work experience. That's often something that in all industries, you know, when we have our panelists talking to our young people, they really recommend doing some work experience. Perhaps I'll throw to you first, Sam. Do you think work experience is a good way to get some life experience and potentially explore if science is the right area for you? And how would they do it?
Absolutely. I mean, work experience in general changed how I saw the world. I mean, I came out of school and didn't feel I was ready for uni and went and worked a fairly menial job for a year, but I saw sides of just life and people that I knew nothing about. And I think that was really a good thing. It sort of made me that little bit less sheltered, I think, which was good. For me, that was good.
Right.
As for science, you know, there's so much out there. You can maybe look to local industries if you think there's something there that's, you know, interesting to you and it's not too far to travel. But absolutely, it's the more experience, the better, really.
Excellent. And over to you, Aleks. What about your ideas on work experience and maybe some ideas if there's some young people out there now, where would be some great things to go and try and gain that experience in?
Yeah, thanks, Renee. Just reiterating what Sam said, I do think that work experience is a great opportunity to help a younger person understand what they're interested in and what works for them and what doesn't. I think it can be difficult sometimes to get work experience in the industry that you're looking for. I think the best way, at least in my experience, is to work with your school, facilitators for the work experience, to try and find those opportunities, because they generally have a better idea, I suppose, of the industries that are available and the opportunities that are available. And so, for example, if somebody would like to come and do work experience at the Antarctic Division, we encourage that to come through the schools. And I think other industries are probably trying to do the same thing, because it can be difficult with individual approaches. So I just suggest working through the school and proactively talking about things or discussing things that you're keen to do.
Great. I might just stay on you, Aleks. So we've had a question pop up regarding and asking, what course could I study here in Tasmania if I wanted to spend time in Antarctica? Well,
there's lots of different disciplines that are appropriate for Antarctica. For example, there's a number of sort of physicists that work in Antarctica, whether it be on climate or ice sheet modelling or understanding the dynamics between the ocean and change in the ice sheet. Or, as I've done, you could look at the ecology and the biology. I think the important thing to do is get a good grounding in the science that you're interested in university. And then as you start to get towards the end of your university degree, look for postgraduate opportunities, whether it be through honours and then through a PhD, looking down the track, that can actually be more targeted to, or in collaboration with researchers that are involved with, the area, for example, Antarctica, that you're interested in. And that's the best advice I can give on that front. Get a good grounding in science and then look for opportunities as you get towards the end of your career.
Yeah, and something we always say as well, which I'm sure you guys might reiterate, is asking if you know someone that is doing a job, that is doing research perhaps, or is a scientist in something that you'd like to do, maybe having a conversation with them and, asking if you can catch up and ask how they got to where they are and all those types of things. So yeah, that would be a great way, I think, through your, what you talked about with work experience, working through your school, and if you're out on that work experience, sitting down and asking the person how they got
Absolutely.
there. Yeah.
Absolutely. Couldn't agree more.
Great. All right. So now just to wrap things up for today, we've got some final brief advice from our panellists, Sam and Aleks, about what messages they'd like to leave you all with today if you're thinking about pursuing a career in STEM. So Sam, let's start with you. What's some final advice that you'd like to leave our young people that are here with us?
I mean, it's the final thought, and it might sound a bit cliched, but if you're interested, dream big. I think one of the biggest roadblocks to making a better world is people not thinking they can. and you can all achieve great things. You've just got to be willing to try. So yeah, get out there and make sure you enjoy yourself.
Great, great advice. I love it, Sam. Thank you. Aleks, over to you. What's some final messages that you'd love to leave our students?
Well, we can't say it enough, but do what you're passionate about. But I also think staying flexible, I think expand your horizons when you can. As Sam said, go and live overseas if the opportunity arises. See these opportunities and grab them, because often opportunities don't come along that often. And when you see a good opportunity, make the most of it. Stay flexible and, yeah, I guess work hard. That's been my motto. So thanks.
It's great, great final advice. Thank you. Can we all please give a big virtual round of applause for our panellists today, Aleks and Sam. Thank you so much for giving up your time. I know how busy you both are. We really appreciate it. These sessions cannot run. We just cannot provide them without the likes of people like you. So we really appreciate it, and especially having such amazing panelists like yourselves. And please don't forget, everyone out there, we have a lot more industry live events coming to you between now and the end of 2020. So please don't forget to register. Check out our full program on our Industry Live webpage. And in addition to our normal program, we have also been running a series of special events called Bconnected, which actually finishes this week, featuring our Test cricketing captain, Tim Payne. The series is aimed at maximising health and wellbeing while students are learning from home. So be sure to check out the recordings of that Bconnected series, and also some of these Industry Live sessions going on our Beacon's YouTube channel. So please don't forget to subscribe to the channel. So without further ado, thank you so much to everyone that has joined us, and for those watching on our YouTube channel. It's been a pleasure talking to Sam and Aleks, and hopefully we've inspired you to step into that science career. So we look forward to seeing you all next time. Thanks again for joining us.